Hello everyone. Today in this video we will discuss about curvilinear motion and circular motion topics. First of all, what is mean by curvilinear motion? Other than the straight line, motion of any particle is along a curve. Then that type of a motion is nothing but a curvilinear motion. Now whatever the particle which is moving in a curvilinear path will have some velocity and acceleration quantities. Now we will see all the components for the velocity as well as for the acceleration of that particle. Now coming to the components of the velocity, same like force, that is resolution part, velocity also is resolved into two components. One component on the x-axis and one more component on the y-axis. So Vx first component is given by dx by dt, and the second component, that is Vy, is given by dy by dt. From these two components, rectangular components, we can get the total value for the velocity by square root of Vx square plus Vy square, and direction is nothing but theta value of that velocity with respect to the x-axis. That value is given by tan inverse of V by y Vx. So these are the two rectangular components formulas of the velocity, and to calculate the total velocity we can use this formula in the problems. Now coming to the acceleration of a particle, that particle which is moving in a curvilinear path will have the two components. First component is tangential acceleration and the second component is normal acceleration. And for the normal acceleration, two more names are there, centripetal acceleration or radial acceleration. Now coming to the first acceleration, tangential acceleration. The rate of the change of the velocity with respect to the time is nothing but tangential acceleration, and it is denoted by a suffix small t, and it is given by dv by dt. Now coming to the second acceleration, normal acceleration or radial or centripetal acceleration, the change in the direction of the velocity is nothing but normal acceleration, and it is given by a suffix small n, and it is given by v square by r, where r is nothing but a radius of the curvature in the curvilinear path. From these two components, at and an, we can calculate the total value for the acceleration of that particle, and it is given by square root of a n square plus at square. So these are the formulas to calculate the components of the acceleration and to calculate the total acceleration value of that particular particle which is moving in a curvilinear path. So once again, this is the curvilinear motion and rectangular components of a velocity and acceleration of that particular particle which is moving in a curvilinear path. Now we will see the circular motion. Now what is meant by circular motion? If any particle is moving in a circular path, then that type of a motion is nothing but a circular motion, and a circular motion is nothing but a special case of a curvilinear motion only. And we can say that any particle is said to be in a circular motion if its distance from the fixed point. Distance is nothing but radius value of that particular circular path from the fixed point. Fixed point is nothing but center point. So r value in the plane of the rotation is constant. Whenever that radius value from the fixed point in a circular path is a constant value, then we can say that particle is in a circular motion. Now we will see the differences between two motions, that is rectilinear motion, linear motion and circular motion. So under the kinematics part, we will get the terms like displacement, velocity and acceleration. Now we will see all the formulas, all the relationships between the linear motion and circular motion. Now generally displacement is denoted by s in the linear motion, and it is denoted by theta in the circular motion, and the final velocity is denoted by v in the linear motion and omega in the circular motion. Initial velocity is denoted by u in the linear motion and omega naught in the circular motion. Acceleration is denoted by a in the circular motion and alpha in the circular motion, and all these terms in the linear motion are nothing but linear quantities like linear displacement, linear velocity and linear acceleration. And under the circular motion, these three terms are nothing but angular quantities like angular displacement, angular velocity and angular acceleration. Now we will see the formulas when we compare the linear motion and circular motion. Generally ds by dt is equal to v, that is nothing but rate of change of displacement is nothing but velocity, and rate of change of velocity is nothing but acceleration. So these two are the formulas under the rectilinear motion, under variable acceleration. So in the linear motion, so these two formulas again you will get in the circular motion also in the same manner, but in terms of the angular quantities, like rate of change of angular displacement with respect to the time is nothing but angular velocity, and the rate of change of angular velocity with respect to the time is nothing but angular acceleration. So you will get the two formulas in the linear motion and in the circular motion in the same manner, but in terms of the linear quantities in the linear motion, in terms of the angular quantities under the circular motion. And here omega is nothing but angular velocity, so that formula is given by 2 pi n by 60, where n is nothing but speed value. And what are the direct relationships between the linear motion quantities and angular motion quantities is nothing but with the relationship of the radius value of the circular motion only, that is nothing but s is equal to theta r, linear displacement is equal to angular displacement into radius value, and v is equal to omega r, linear velocity is equal to angular velocity into radius of the circular motion. Next a is equal to alpha r, linear acceleration is equal to angular acceleration into radius value. So these are the direct relationships between the linear motion and circular motion. And now we also know that there are four formulas under the rectilinear motion under the uniform acceleration. So these are those four formulas under the linear motion. Now we will get these four formulas under the circular motion also in the same way, but in terms of the angular quantities, like v is replaced with omega, u is replaced with omega naught, a is replaced with alpha, t will be same only, t value only. So in the same way you will get all the four formulas under the circular motion. Now coming to the units, displacement units are meters, velocity meter per second, and acceleration meter per second square. In the circular motion, angular displacement units are radians, angular velocity units are radians per second, angular acceleration units are radians per second square. So these are the units. Now once again, differences between the linear motion and circular motion. These are the terminology and abbreviations. Next, these are these two formulas are under the variable acceleration formulas. Next, these three are the direct relationships between the linear motion and circular motion. Next, these four formulas are under the uniform acceleration formulas. Next, these are the units for the linear quantities and angular quantities. Angular quantities are nothing but under the circular motion. Once again see all the formulas. Now based on these formulas we can calculate any problem under the linear motion and circular motion, again based on the trial and error method only. Now we will see some problems. So here this is the first problem. Here a flywheel which is at the rest is nothing but initial velocity will be 0. So as this problem is belonging to the angular motion, circular motion, omega naught value will be 0. So omega naught value is equal to 0. Next, attains a constant speed of 300 rpm. So n value is given as 300 rpm. So based on that n value we can calculate the omega value. Next, after accelerating uniformly for 10 seconds. So time value is given as 10 seconds. Now what we have to calculate? Determine number of the revolution made by the flywheel during this speed. So number of revolutions is nothing but angular displacement quantity only, that is nothing but theta value. So they are asking to calculate number of the revolutions, angular displacement, that is nothing but theta value. Now how to calculate the theta value? There is no fixed formula to calculate the theta value. So we need to use the trial and error method, and by using all these four formulas we can select any one formula according to the given data. We can select any formula according to the given data, and we need to calculate the theta value. So here, to calculate the theta value, alpha value, angular acceleration value is not given in the question. First of all, we will calculate the alpha value. So to calculate the alpha value, we need the omega value. That value also, that is not given in the question. Only n value is given, that is speed value. So based on the speed value, n value, we know one formula. Omega is equal to 2 pi n by 60. So substitute that 300 in this omega formula. Then you will get the omega value like 31.416 radians per second. Now we know the omega value, omega naught value, and time value is given in the question. Now according to the first formula, that is V is equal to U plus AT. Now change that formula in terms of the angular quantities. Then you will get the formula as omega is equal to omega naught plus alpha t. Now substitute all the values in this formula, you will get the alpha value. Now what is the second formula? S is equal to ut plus half at square. Now change that formula in terms of the angular quantities. You will get this formula like theta is equal to omega naught t plus half into alpha t square. Now substitute all these calculated values and given data in this formula. You will get the theta value, number of the revolutions in terms of the radians, like 157.08 radians. But they are asking to calculate number of revolutions. That is nothing but according to the time. So if you divide this radians by 2 pi, you will get in terms of the units like revolutions per second. So you got the value number of the revolutions as 25 revolutions per second. So this is the problem. This is the calculation part. Now we will see one more problem. Here a 600 mm diameter flywheel is brought uniformly from rest to a speed of 350 rpm in 20 seconds. So from rest is nothing but initial velocity, angular velocity is 0 value. Next, n value, speed value is given. So from the speed value, by using the formula 2 pi n by 60, we can calculate the omega value. So we got the omega value. Next, time value is given as 20 seconds t. And next, one more thing, here 600 mm diameter. So 600 mm diameter is nothing but everything should be in terms of the MK system only. That is nothing but meter, meter per second, and meter per second square, or radians, radians per second, or radians per second square. So but this value is given in terms of the mm. So convert this mm into meter. So here diameter value is given. So from the diameter we can calculate the radius value like diameter by 2. So we will get the radius value again in mm. So convert that mm into meters, like 300 by 1000, you will get it as 0.3 meter. So this is the radius value. Omega naught is equal to 0 as it is starting from the rest position. So 0 value. Next, from the speed value you can calculate the omega value. Next, they are asking to calculate, determine velocity and acceleration of a point in the rim 2 seconds after starting from the rest. So again separate time is given. After that 2 seconds they are asking to calculate velocity and acceleration. If they mention simply velocity and acceleration, those are nothing but those are the terms under the linear motion. So linear velocity and linear acceleration. So for to calculate the linear velocity and linear acceleration, enough data is not given in the question. So we need to calculate the alpha value and some more quantities based on these things. So first of all we will calculate the alpha value. So here we know omega value and time value is given in the question as 20 seconds. So based on those data we can calculate the alpha value by using the first formula, that is omega is equal to omega naught plus alpha t. So substitute all these values in the first formula, you will get the alpha value. Now after 2 seconds we need to calculate the velocity and acceleration. So after 2 seconds we will calculate the angular velocity value again by using the first formula only. So omega is equal to omega naught 0 value, again here from rest is given. So 0 plus alpha value we have already calculated into time is given as 2 seconds. So substitute 2 value here. Then you will get in terms of the angular velocity after 2 seconds. So we need to use this angular velocity after 2 seconds to calculate the linear velocity after 2 seconds. Now what is the direct relationship between the linear velocity and angular velocity? V is equal to omega r. Now we know the omega value and we know the r value also, like 0.3 meters. Now substitute these two values in this direct relationship. We will get the linear velocity. Now how to calculate the acceleration? We know that acceleration is resolved into two components, tangential component and normal component, and we know the formulas also. Now at is equal to alpha r. We know the alpha value, we have already calculated, and we know the r value, that is directly given in the question. Now substitute those two values, we will get the at value. Next, an formula is v square by r. V is nothing but linear velocity only, that we have calculated here. Next, r value, that value is given in the question. So substitute all the values in this formula, we will get the an value. Again from the Pythagorean theorem, we know the total value for the acceleration. Formula is given by square root of an square plus at square. So by using that formula and substituting these two formulas in that formula, we will get the total linear acceleration value. Now see the problem once again. This is the calculation to this is the problem to calculate the linear velocity and linear acceleration. So these are the problems under the circular motion, under the uniform acceleration. Now we will see one more problem, circular motion problem only, under variable acceleration. Under the variable acceleration means we have to use the differentiation method. Now see here, the angle of the rotation of a body is given by the equation theta is equal to one equation is given. So here theta is nothing but angular displacement only. Next, here they are asking to calculate angular velocity, that is omega, and angular acceleration, that is alpha, of the body when t is equal to 0 and t is equal to 4. So here directly t values are given in the question. So we need to substitute these two values in the equations of the theta, omega and alpha. Then we can get the values of omega and alpha value. Now here theta is nothing but angular displacement equation only. So make it as the first equation. Now if we differentiate the theta value, we will get the omega value. That is nothing but rate of change of angular displacement is nothing but angular velocity. So differentiate this equation. You will get one more equation. Make it as the second equation. Next, again differentiate this second equation. You will get the alpha value. That is nothing but rate of change of angular velocity is nothing but angular acceleration. So we will get the third equation in this way. So first, second and third equations, angular displacement, angular velocity and angular acceleration. Now what we have to calculate? Angular velocity when t is equal to 0 and t is equal to 4. Angular velocity is nothing but second equation. So substitute this 0 and 4 seconds in the second equation. In the second equation, you will get the omega values in terms of radians per second. Next, angular acceleration, that is nothing but third equation. Again substitute t values in the third equation. You will get the alpha values. So this is the problem. Under circular motion, again under variable acceleration. So completely we have two types of the motions. That is, first one is rectilinear motion and the second one is circular motion. So you will get the separate formulas under the linear motion and under the circular motion. So we need to identify the problem, whether it will come under the rectilinear motion under uniform acceleration, or rectilinear motion under variable acceleration, or circular motion under uniform acceleration, or circular motion under variable acceleration. Completely 4 types of the problems will be there. So you need to identify the problem first of all, then you need to apply the formulas. Again, according to the trial and error method process only, you need to calculate the problem, as these all the 4 types of the problems will come under the kinematics part only. So these are the problems which are related to circular motion and linear motion.